Hey, hello students. Here I'm back again with the lesson number 2.3, and I'll begin with examples first. So the learning target that we have already seen in the classroom, but yet I would like to no, this is the one I've not gone through yet. But what is the learning target for the lesson two 2.3? Is the main objective of the lesson uh, is solve probability application using complement. So we need to know today's lesson is more about what is a complement, complement of an event. So we already know what is the meaning of event from the last lesson. So when you have a sample space like this, when you roll a dice, the sample space, the number that shows up could be any of these one, two, three, four, five, six, right? Now, what is the meaning of an event? Basically means a subset. Event means subset. What does it mean? It is the some set of numbers, something here, but those has to be only from here. So that's why we call it subset. And that could be, it depends on what is the description of that event. Could be, let's see, the even number shows up. So your new event would be uh, 246. That's what it is actually. And I'm always showing this example to get an idea what is an event. Now, what does complement rule means? Okay, let's take that complement rule and then find the probability when there is a union of two events. And the next one is the intersection. So two, these are the three things we are going to learn today. And I would like to show before I go with an example, I will take my own example of, let's see, we are our classroom. This is our classroom, and we are 14 of us, and let's see, there are 8 boys and there are 6 girls. Okay, so this is our total number, which is n of s. And if I want to pick a student, let's see. So let A be an event. If I select a student from this, an event A that a picked up boy, sorry, a up, picked up student is a boy. Student is a man or boy. I can't say boy for you guys. You guys are men and women, so I right. Maybe man. Okay. So man is plural. I mean singular. And when I write E, that's like many of them. If I write A, it's just one. Now so these are instead of boys and girls. I'm gonna use it like uh man and woman. Okay. So what is the picked up student is a man. So that means what are our options, right? So how many men? And you can see there are 8 of them. So it's like man one, man two, man. So man three, man four, like this, right? And five, and six, and these are all 7, 8 men. And I want to know what is the meaning of complements. Now, what does that mean? Let's find out if A is if A basically means all these men. Now complement. So what is the meaning of this? Is complement of event A. Now complement means all the rest of the students here, but not who are. So it is an event that the student chosen is other than men. So not men. So this also means complement of an event A means not men. So if it is not man, that means you're talking about uh, from this 14. That means I'll call this as B, a new event, which is complement, and that will be all the women. That means woman 1, woman 2, woman 3, woman 4, woman 5, and woman 6. So that means A and B are complement of each other. See, complementary, complement events. It means A is a complement event of A and B is a complement event of. So in other words, if I want to write A is all the S, the whole entire S basically means 14 of them. This is S. So from S, it is you take away the, or you can say the B. Let's put it like boy. So if I want to know the B, it means B is all woman, right? So if B is all woman, let me write it neatly what I'm trying to say. So B basically means right here. I can also write this as it is all of the total 14 of them, blah, 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 blah. All 14 plus all 14 men and women. But from here, you're taking away man. You're taking away man, M1, M2, and like this till M of 8. So that's what this B is. B basically means everything from here, but other than the woman, I mean, other than the man. Now, if you get confused with this, we'll take one more example. And I know it is confusing. So let's see. Now, in this case, also we can find let's see, what is the probability that when you pick up a student, let's see, and there is a nice thing happening here, that probability of A. So watch this. Mm, so if I want to find what is the probability of event A, you can see A is when you pick a student, the student is a man. There are altogether 8 men here. So this is the ratio of all the total students, which are 14, and from 14 that you can pick any of this 8. So the 8 over 14. Now, what is probability of B? Now, what is probability B means? It is again the same thing, 14, but this time it's going to be not man. See this? So other than, it means they are all women. But you can also say complement of an event A means not man. It means they are all women. So that means how many women are there? Is 6. So it becomes 6. So if you try to add these two pieces, let's see what do we get here. I'm gonna show you a formula that helps us. So if I write down, add this to, let's see what is probable. I want to add this to probability of A plus probability of B. And you can see now probability of A is 8 over 14. Okay. And probability of B is 6 over 14. So this green color, this is 6 over 14. That's like not man, right? Remember, I defined B means it is the complement of A, means it's opposite. Whatever this has all man, but B means not man. That means all woman. So when you do this, I write 6 over 14, and you see 14 is a common in the denominator, and you can add 8 and 6. 8 plus 6. And 8 plus 6 is 14 over 1, and 14 over 14 is 1. So what did we learn here is that probability of A plus probability of B is 1. See, that means now we can write down, there is another symbolic way to write. Symbolic way to write is, this is probability of A. Let's see. Another way to write is, so this was the event given, this was the event given. This was the all man. And then when I say complement of A, we said let's call it as B. When you write complement of A, basically it means it is written as A raised to small c. So that's what the meaning of complement of A means, the outcomes which are other than the A. So I will give that example later. So when you write this, this answer is 1, and we can write this as Probability of A, probability of A plus, instead of B, I can write it as probability of B complement is 1. So if I want to write probability of B complement, it's like if I add this plus this is 1, that means one of this will be equal to 1 minus probability of A. See, this is the formula, and that's called a complement rule. So, so one thing is that A and A complement, A union. What is, there's another now. I'm using union basically means if you combine A and B, this means you're combining A and B. It means it's going to be all men. That means M1, M2, M3, like this, all 14 of them. And you're combining also all women, right? There are 6 of them. So all together this becomes the total, which is the sample space. So so what did we learn from here is what did we learn here is if A is an event, then the complement of A is A complement. That's all it is. And then what happens is if you combine A and A complement, you end up getting the whole sample space. And when you write probability of A and plus probability of B, that's 1. I mean, A complement, this is like A complement. And probability of A complement is always 1 minus probability of. So these are the things we are going to use in the example and understand what does that basically means. Let's take one more example. To understand this piece, well, let's take an example of a dice, right? When a dice is rolled, and the option that we have is this is the whole sample space. I'm sure you agree with me this. I know you got confused with the earlier example. Let's take this example and let's call A as an event, something where the number is uh, uh, greater than 4 shows up. Uh, so when you roll a dice, what is that like event A describes it is the number is whatever that shows up here is bigger than 4. Now what are the number that are bigger than is greater than 4 is it is 5 and 6. See, there you go. The moment you have this, you can even write the probability. What are the probability that when you roll a die that you're going to end up getting 5 or 6 is it's a ratio, and you can see here it is all there are 6 options here, so that 6 will go down. And the A that you see here, it is like number of outcomes in A, there are 2, and the number of all possible outcomes in the sample space is 6. So this is 2 out of 6. See, I'll just keep it 2 out of 6, even though you know it is, if you divide by 2, if you divide both numerator by 2 and also denominator by 2, your fraction reduces to 3. But I'm going to keep this, I have a reason to show. Now, what is the meaning of complement of A, right? So what is the meaning of complement? Complement of A is, we can call this event, new event complement means other than A. That means I can call this as, let's say, D. D is a event which is complementary to A, means opposite to A. It also means not A. It also means other than A. Other than A. Other than A. Now, other than A basically means now A has 5 and 6. So which are the numbers other than 5 and 6? And you can see the blue ones. So the blue ones are other than 6. So it is 1, 2, 3, and 4. See, that's all complement means just picking from the sample space. You have to write the other numbers than whatever this piece is there. And you can say another way to write this, I call it D. So you can call it D, or you can say complement of A. So it's the same thing. And when I want you to, what I'm trying to say is this one you got probability of here, probability of A is 1/3. Okay. And let's see what was the probability of A complement. And you can see probability of A complement, which is also, I wrote it like, is a new letter I use D. D. It means the outcome that show up here is other than 5 and 6. So you can see there are four of them. And you can see this is n of A complement is 4. You just write 4 out of 6. You can see that's how the, and if you add this to, clearly not this, I'm going to use this one. Too much of stuff here, right? So probability of A complement plus probability of A, and they both, so A complement is this 4 over 6, and B complement, and the first one is this goes 2 over 6, and clearly it is 4 plus 2. When the both denominators are same, you just write only once and you get 6 over 6, and that is 1. See, that's what we learned. So instead of doing this way, this is the complement rule, or you could also write, okay, so let me write one more time. Even though we take this, I like to show this so that I really, really want you to understand the concept. Is that what we learned is, again, probability of A plus complement plus probability of A. The answer is always 1. Another way to write is probability A complement. In other words, it's like this. I don't know if go on and writing example, then we get lost. Right? Still, I would like to show. We know 2 plus 3 is 5, right? We can also write 2 is a 5 minus 3. Do you agree? Yes, 5 minus 3 also is 2. See? So in other words, this plus 3, which is here, you are subtracting on both sides here. So what I'm talking about, if these two pieces is add up to 1, and if I want to know one of this piece, that will become 1 minus probability of the second piece. So that's all it is. And this is called complement rule. So complement rule. I hope complement rule. Okay. Uh, let's go directly now. And then besides this, there's one more. Now I'm gonna understand there is another uh, new concept called intersection of two events. Now, what is the meaning of two event intersection? Basically means, let's see. Let me give an example of the same thing. Sample space of rolling a dice. We know there are 6 of them, and I can call the first one A is even number. So let's call A is mm, even number shows up. So if it is even number shows up, basically it means it is 2, 4, and 6, right? And suppose B is another event, I can say. What is the event? B is an event which says maybe greater than 3. So B is an event, the number greater than greater than greater than 3. What that means is, what are the numbers which are greater than 3? Greater than, basically bigger than 3, and the bigger numbers are 4, 5, and 6. So that's it. Uh, we can show this something by Venn diagram. So I'm going to show something. What is Venn diagram? By using circles or ellipses. So let's see, the whole box is called, we'll make a big rectangle called sample space, which is all possible option, all the 6. This is a sample. And then we have A is 2, 4, 6. So I'm going to use two ellipses or circles like this. So one is this, no, not this one. And then another one I'm going to use a green color. Okay, like this. So what this basically means, and there is a space that you see in between which is common. So this is the space, and you can see the numbers which are common here. Let me use red, no, no, not red. I'll use the blue color. So this four is a even number. Six also is even number. But that four is showing up in the first one also, and it is showing up in the second one also. So it's showing up A and B. So it means if this is the red one is A, so if the A is the red circle and B is the event circle, that means the one that 4 and 6 that shows up there, the blue color is, I can put them here 4 and 6. These two numbers go. That means on the left side, even number because this is even, right? And this is greater than 3. So the other numbers will fit in. So we need to fit in the red one. We have to go 1, 2, 3, correct? 2, 3. So this will be the numbers for. Oh, sorry, not this one. Only two. Yeah. So the number 2 only fits in there, and the green color will be whatever 5. Yeah. See. So clearly, the red one is the 2, the green one is, and so you may ask, what about the other number? When we're using the black color, I can say, what about 1 and 2? Not 1 and 2, 1 and 3. So what about these two pieces? So these pieces will be outside this one, maybe here. So this dot is like 3, this dot is like 1. That's what. So each of these numbers can be represented. Put a dot here. Dot is 4. This dot is 6. Or you don't have to put it. Just put this. Uh, so this is how. So I'm trying to say, what is the meaning of What is the meaning of, we want to know intersection, right? The intersection of two events means A is an event, B is an event. So A intersection, A intersection B. Now the symbol is A and inverted. This is what is it's like inverted U and B. It means whatever that you see common in both cases. So it means here this becomes equal. So the intersection is it's a set, and the set is only this blue color. So this 4 and this 6. These are in the red. These are in the red one also, and they are also in the green. So that's what it is. They are common, and because they are common here, they appear in both the sets. And that's why I say the 4 and 6. That's it. So that's the understanding of intersection. It can so happen there's something called disjoint. Now, what is the meaning of disjoint sets? Disjoint events basically means if there's nothing common. I can create another event saying odd number shows up. Odd number shows up. Now, which are the odd numbers? The odd numbers are 1, 3, 5, right? And you can see if I want to do this way, okay, so I'll have to have a new separate. So let me take this whole thing out. As I said, S is 1, 2, 3, 4, 5, and 6, right? So A is an event that is even numbers 2, 4, 6, right? And B was the event separate. Okay, don't worry about it. Now I want to work on only this one, and the B is an event. Uh, this one even number shows up. This one odd number shows up. So what that means is the numbers are 1, 3, and 5. See, and you can see here. Do you see any of these number which are? Do you see anything is common here? They're all different. See, so that's why such cases when you don't see no number repeated in this, so no number repeated. So if you don't see no number repeated, we say this A and B are called these joints. So they are called these joint. events. And how do we write symbolic? We write A intersection B, and we say we don't see anything common, just it's blank, so there's nothing inside. Or you put a kind of circle and put a bar, so that means or null set. So these are different ways to say that there's nothing there. Okay. Now let's go to another one, the last one, called union of two events. What is the meaning of union of two events? So this is the concept for this lesson. That's why I'm walking. Before we go to directly to the examples, I felt to show this. And let me take this directly and start with what is the meaning of union of two? Union of two events. Now I'm going to take the example, the same one, because it helps. This is one, two, three, four, five, six. And let's write down two events. Let's see, A. A is, let's see, A is prime number. Okay, prime number. Now, if you get confused, what is a prime number? Prime numbers are 2, 3. These are the prime numbers because you know why? Because 2 can be divided by only 1 and 2 can be divided by 2. 3 can be divided by 1 and 3 can be divided by 3. 5 can be divided by 1 and 5. So there are exactly two divisors. So the number one that you see here, one, and the number itself, whatever that is. So that those are prime. So if I say A is an event, so A is 2, 3, and 5, right? Sorry. If you understand this, you can fast forward also. I'm just trying to show everything. So these are prime number, right? These are prime. I can create another event. Let's see. Maybe D, F, G. Let's write G is another event where the number is maybe less than 4 or less than 3. Less than less than 3. Okay. So what is the meaning of what does so less than 3 basically means 1 and 2, right? So the meaning of union A union G. So it means that we want it means you write all this 2, 3, 5. So it is 2, 3, 5 A. And in addition to that, you also put this also, that is 1 and 2. See? But normally this is correct. But we write since A is the number which looks same, so you kind of write only once. So I'll start with 1 and 2. I'll write once, even though it is showing up to but 1, 2, 3, and 5. And this is called union of union of two events. So that's the meaning of two events. And then we will also have two formulas based on this. I hope I make you understand that mm, why, what is the meaning of union, and now how do we show this with the help of with the help of uh, let me clean this. How do we show with the Venn diagrams here? So if this is the S, okay, and I'll try to do two ellipses. These are called two ellipses to help us. The whole thing is called Venn diagram. It just helps us visual understanding of what's happening. S was 1, 2, 3, 4, 5, and 3, 4, 5. And uh, the first one was, I think there was 1, 2, if you remember, A was 2, 3, and 5, because that's the prime numbers. And the other one, G, was a number greater than, I forgot what was it, greater than, I think I think I said less than 3. Okay, I said less than 3. I don't know what I wrote. Anyhow, I just make less than 3. Less than 3. So if it is less than 3, it means it is 1 and 2. And then I combine these two. And when I combine A union G, and you can see there's a 1. I'll write 1. The 2 is there in two places, so I'll write only 1. and then this 3, and then 5. See? So A has 2, 3, 5. So 5 is the one that is common. So let's put this red 5, which is common. I'll put it here. And A has 2 and 3 also. So this 2 and this 3 will go here. And G has, this is G, right? G has 1 and 2, but 1 is already written down. So we'll take, I'll use pink color. So I'll write this one pink color here. I'll write it here. See? And this whole thing. So where is what are the numbers left out is the black color, which is I think I missed here. So 6 is missing, and also 4. This 4 and 6 are not here, so they are outside. So this is 4 and this is 6. So this will be outside these two. See. So these are. So what is the meaning of basically? Basically union. So what does this EA union mean? It's like all these areas. And look at this, how beautiful this whole thing. This is that. And last time that we had seen intersection, last time that I had done two circle like this to show, and then there was A and B, and then intersection was the one that is common for both. That means this was the one. So this is the understanding of this. I hope I'm making sense. And we have a nice formula here called addition rule. Now, what is the meaning of addition rule? And the addition rule is probable. If I want to know what is the probability of of course, here you by the look at it, you know that what is the probability of A union G? A union G is there are four of them. See, there are four here, so it is 4 out of 6, and you're done. Okay? So that's the probability of A union B. But there is a formula also to figure out directly, and that is probability of A union B. And you can see that A, it means you first add this piece, so this part, which is probability of A, and then you add up probability of this one. This is the G. If I write B, let's call this G. I'll use it as B because of the formula. Okay, so this red color and plus probability of B. And then you also see there's something by you added up 5 twice. So that 5 is in this also and 5 also in this. So what all you have to do is you have to take away that 5 from probability of A intersection B. So you're taking away from so because this 5 is repeated, right? So it's repeated here in the beginning we are saying probability of A is this whole thing like 2, 3, 5 out of, and then after that you are saying this one. That means you already repeated with this 5. So you have to take off that something that is common. What is this intersection basically means this 5 which is common. So let's see whether we are right. So A union B, so probability of A basically means 2, 3, 5. So there are 3 out of 6, right? Plus, and what is B is this is that B, instead of G, I'll take it B back to B because of the formula. That's 2 out of 6. And this A intersection B minus, intersection basically means we saw there was only one of them, see? So there was only one which is common. This is 1 out of 6. And if you do little maths here, the denominator is 6 for all of them. See, all of them 6 is the denominator. And the numerators are written exactly the same. 3 plus 2 minus 1. When you work out, this will be 5 minus 1 out of 6. So that is 4 out of 6. And that's what we got here also. So this formula is the works. So basically what we learned here is, I know it is a little confusing, but that's how it is. I'll clear this to show that what is that addition rule. So what did we learn here is something called addition rule. And what is the addition rule of probability? Rule of probability is B, Lee, and the probability of A union B is probability of A plus probability of B uh, minus probability of A and B. I hope. So that's the formula. We are going to use this. Uh, the only thing, take note, in case A and B are become disjoint, what is this? A and B disjoint basically means when you don't see A and this is A and this is A and this is B, and you can see this is a sample space, and you can't see they don't touch each other at all. There's nothing common. The disjoint, which means this piece is there's nothing. It's like zero. So this whole formula reduces to this is a special case that probability of A union B becomes probability of A plus probability of B. So minus actually it is zero over n of s because but then since there is nothing common between those two, we reduce this to only this. So that's a beautiful formula there, and we'll see how to use this. And you can see the definition part already there. The starting, if you look at it, this piece is a complement of an even, and also it's also said not E. See, not E or E complement means the same thing here. And this is the formula. Probability of a complement is this one. So 1 minus, which I already showed. And this one, so when you add those two, you get 1. Or you can write this also. Let me go straight away to example number, I think this is 1.1. Okay, if you pull a random card from a deck of cards, and you can see a deck of card, this is a deck of card, let's say. There are altogether, deck of card contains 4 suits. So you can see there are black, which is a club. There are 13 of them, and there is also another black which is a spade. So you have spade, this one. There are 13 more, and you have diamonds, which are again like this. There are 13 of them. Mm, this is diamond, and then there is also heart, right? So this is heart, and these are 13. So they all add up to 52. So there are 52 cards. So this is very important to understand that this is the clubs, spades. So that's the club. This is the club. This is the spade. Okay, and this is the diamond, and this is the heart. So the question is, if you pull a card from a deck of cards, this is a deck of cards. What is the probability is not heart? See, it is asking a probability of not heart. So we can write this probability not a heart. So the shortcut, not a heart. Now, right way to do is you can use common sense also. In the four suits that you see, not a heart. So hearts there are 13 of them, see. So you can use your common sense and say, hey, all of them are 52 cards, and from 52, not a heart, right? Not a heart, basically you subtract this and you get 13. I mean 39, sorry, 39. So probability becomes out of 52 cards, so it is 39 and you're done. So that's like actual way to do. But I'm gonna use the what is it called? Use other rule that is called complement rule. That means I'm gonna use this piece. Watch this. I'm gonna use exactly this piece. So this not basically means not a heart. I can say this is probability. Let's say heart, and this is what it is. It means H is card is a heart, right? Card is a heart. And H raised to C means card is not a heart. See, so simple, not a heart. That's all it means. So these are written in words, not a heart. Is same as saying probability that it is you can use 1 minus the formula says. We use the shortcut formula, and the shortcut formula is 1. Can you see this 1 here? So it is 1 minus probability, it is heart, just opposite. So if it is probability of not a heart is always 1 minus probability it is a heart. So it is 1 minus Now, if and we know what is probability of a heart because there are 13 cards here. You can see the red, there are 13, 13 out of 52. A little work is required here, and I hope I'm making this visual clear to make sense to you. So in this case, this answer, so I'll have to multiply because there's a 52 there down. You can see the denominator is 52. I'm gonna multiply 52. Oh, there's like a room. Let me make a room here. So I'm gonna multiply 52 and also divide 52. Why do we do this? So that you get 52 divided by 52 minus 13 divided by 52. And that it becomes now 52 is the same for both. So I'll put it here. And then the numerator I've written exactly the same because you already wrote the denominator. And if you do this, that becomes 39 out of 52. See, and you're done. So that's what this was, 39 out of 52, which we can still reduce this. Not always this can happen because this is a common sense. You can see there are 13 plus 13 plus 13 plus 3 of them become 39. So if you divide by 3, that's like 3 up here. And if you divide this by 3, it is like 39, which we can still reduce by 3 and say this 1 out of. I'm sorry, I'm making a mistake. I'm dividing by 13 here because there are 3 of them. 3 13s gives you 39. That's why. And if you divide this by 13 here, the third that is there are 4 of them. See? So if you get confused, we'll see each one of these example and I'm talking. I'm going a little fast here. Basically, what you get is 3 4. That's all it means. So I hope I'm making sense. There's too much of stuff here. I think I better make it a little smaller. This piece is too big, so there's no enough room to write. So let's pause for a while. A quick understanding of deck of cards because that's we are going to come up with this again and again. So you have 4 suits, right? You have diamond, you have diamond. So you have 4 suits. One is uh, heart, diamond, spades, and club, right? Every suit has 13 cards. So you have to know that ace card. This is the ace card. And there's 2, 3. These are number cards, 10. And these are called face cards. And you're going to have the same thing for all 4 different suits, right? So for the diamond, again you have 13 cards. So these are 13. 13 plus 13 means 26 red cards. So you have to know this, okay? Then when you go to the clubs, the black ones, see the black is this is a spade. These are 13. These also are 13. And they add up to 26. And this 26 and this 26 together is 52. See? So main thing what we're understanding is how many face cards. These are face card. These are number card. Ace is different. They will say ace card. Okay. And if it is a if the card with 10, if I want to pick a card and it is 10, so there will be 4 different. There will be 10 of. So if it is 10, there will be 10 of hearts, or it could be 10 of diamond, or it could be 10 of spade, or it could be 10 of club. So there are 4. So each of these, there are always 4. 4 aces, 4 jacks, 4 queens, 4 kings, 4 nines, 4 6, and like that. So let me straight away go to the problem then. Now, this is such a simple example, and it's just asking you if the weather forecast predicts that there is 20% chance of rain. And you say 20% means out of it's like you're just giving a value for every 100 days. Let's see, there is 20 days. It's like that. It basically means it is 0.20. Okay, in the decimal form. What is the percent chance of it not raining? Not raining is the word which is very important. So probability that not raining. So if you are asking it is not raining, all you do is just use the complement rule. What is the complement rule? Complement rule says you always have to write 1. From 1, you subtract the complement event. The event is not raining means the, the opposite of that is it's raining. See, so simple. That's all it is. And they already gave you this answer, and this is right here, 0.20. Now this answer is 0.80. How did we get this? Because 1 minus, if you subtract 20 like this 0 point, and you can see little work you do. I don't have to show you. You get 0.80. And what is 0.80 means? You multiply 100 and divide by 100. You get 80 over 100, which is common sense, 80%. So basically, without even doing this work, I'm just showing this organizing to show how it works. But by saying in 20% chance is that it's raining, is as good as saying it is 80% not raining. See, if you say 20% raining, that means out of 100%, together is 100%. From 100%, you take away 20%, and common sense, it is 80% not raining. See, that's all that means. Let's go to the next one. So this is the part I already explained to you guys. And you see this piece, what is the meaning of intersection? This whole thing I explained, and then this is the Venn diagram, which means instead of that, one thing I wanted to show you. Sometimes they don't use the sim- so the intersection of this piece, A and so instead of A and B, basically they say A and B. It means whatever the description, it works also for A, it works also for, it has to be common for both. That's what it. So both are same. And this is the Venn diagram. And in an experiment, question number 2, you roll a dice, and what is the find the intersection of E and T. Okay, I think I have to go back to the problem. So it says in an event, you in a single die. So you do this. You already know this has to be 1, 2, 3, 4, 5. Find the intersection. They're asking. What is common? What is this means is what is common for both. Now E is rolled, right? So what does E stand for? The even number. I think we already did. I'm just organizing. This is that thing. And what is the meaning greater than 2? So T is greater than 2 means it can be 3, it can be 4, it can be 5 and 6. And you can see the meaning of E and T. E and T, which is E and T. It means you have a new set. I use the braces like this. So what is that common that you see? You can see this 4, 4 and 6. Sorry, not this one, not this one. So 4 and 6. So you just write 4 and 6 and you're done. That's all he's asking you. But they're asking you not just the event. This is that E, and but they want the oh, they only want intersection, nothing. But if they had to ask her, what is the probability of that's happening, that it is both even and greater than 2. And you can see there are 2 of them. So it's going to be out of 6 because there are 6, right? Regularly, there are always 3, 1, 2, 3. Now you can see I'm repeating the same thing all the time. So together this is a sample space which is 6 of them, and from there are 2 of this which makes this also correct, this also correct. See,